Diagnostic Centre based in the UK. My name is Geraint Jones. I've worked for SKF for about 12 years. I'm the technical manager for reliability services in the UK. I run a small team of online system specialists, and I also provide feedback into the other reliability teams in the UK, of which there are 3, 2 based in Scotland and 1 distributed throughout England. So this little webinar then is just to show the remote diagnostic capabilities of the centre in the UK, a bit of a UK perspective, and I'll go through what the remote diagnostic centre actually is, the philosophy. Then we're going to look a little bit about the workflow, and then a little bit more detail about what the applications and so forth that the UK centre actually does. So before we get going, I appreciate if you could all, to save bandwidth, mute your microphones, turn off the camera, and just if you want to ask a question, just please use the chat button on the webinar, and then we can do questions at the end, if that's okay. Thank you. So the first thing to say then is there are 2 SKF value propositions, one to do with the products and one to do with rotating equipment performance, into which the concept of a remote diagnostic centre, RDC, fits. And the value proposition around products is to provide the market with a broad range of innovative, cost-competitive application-specific products. And that includes anything from bearings. We're normally sort of a bearing company, but it also includes software, lubrication tools, couplings, seals, all of those products. The second value proposition is around the concept of REP, what we call rotating equipment performance, which is a fee-based value proposition where we're striving to maximise customer output and minimise cost while operating safely with a very much reduced impact on the environment. So those are 2 fundamental value propositions for SKF. The remote diagnostic centre components, which is what we can see here in this next slide, comprise a cloud server at the centre, which ours is based in Sweden. That's where our remote cloud services are operated from, although the remote diagnostic itself is in Aberdeen. Into the cloud server, we input data from traditional, what we call expert portable devices. Increasingly, we are seeing with our N-Line Collect environment, the new SKF N-Line Quick Collect environment, smartphones, tablets, wireless sensors also feeding into the cloud server and directly interfacing with dashboards and web pages. Along with the offline portable type, offline portable type devices, we have our online systems and wireless systems also feeding into the cloud server. In the longer term, we actually want to incorporate these devices into our SKF N-Line Collect environment, so that all of the devices are actually in one place, feeding into the server and also into the dashboard and web pages. And we interact with via our remote centre in Aberdeen, via the cloud server in Sweden. So a little bit then about the RDC standard value proposition. What you can see here is, for those that know a little bit about condition monitoring loop, on the outside of this outer loop, you have what appears to be a conventional condition monitoring service offer, where we have data collection into some kind of database. In this case, it's a cloud, something where you have the remote diagnostic centre where we do all the analysis, and the reporting, and the customer normally sits in here. Okay, and then with the customer gets some recommendations and does a maintenance job, and we go around this loop. The difference with the RDC type service is that we can put the customer in the middle of this loop, and then we have 2 other very important loops that we can then get generated. So the first is is a data loop, where we have data in the cloud, the customer can see it, we can all see it, and we can sit together remotely discussing and interacting with all of the data. And this is very important because it means we can make decisions much faster, we're much closer to the data, and we can make decisions on data much more easily. This loop also includes a reporting mechanism whereby we feed back to customers with maintenance recommendations based on exception, which we'll come on to shortly. The other loop, which is in a sense more interesting for us, is this what we would call a knowledge loop, where we have the customer, the RDC, and the engineering team. And the engineering team, in our case, is people such as application engineers who can provide insight into different sorts of bearing configurations, lubrication, etc., and all of our other segment engineering teams and lubrication seals, etc. And so what we're doing is we're taking the data from this loop here and we're turning it into a knowledge loop here by this interaction between the RDC, our engineering teams, and the customer. And then out of this comes not only maintenance type tasks, but some more useful insights around about the reliability, etc. And of course, the idea is that we want to minimize these amount of maintenance jobs by going through these iterative loops. In an ideal world, what we want to do is have the only maintenance job being undertaken is actually further data collection. We want to almost completely minimize or any kind of maintenance interventions, although of course in reality that's not always possible. So in terms of the remote diagnostic service offerings and values, we have machine health data collected either with online or handheld type devices. They can be uploaded easily and accurately to a centrally controlled SKF cloud. In our case, it's in Sweden. And of course, the customer can view his data at any time. It's hardly ever optional. The customer almost always wants to view the data. The normal sorts of analysis that can be carried out, data trending, diagnostic, etc., carried out by experienced and qualified SKF staff on a daily basis, including system integrity checks and status checks to ensure quality throughout the program. There's a lot of local RDCs, and it enables around the world, and it enables interaction with customers, with the local service engineers in their own language, and that can be quite important. Event reports are a starting point for improvement of projects. So the event reports would be in that data loop that we showed you earlier, where we're reporting on exception to the client to provide possibly some immediate action to carry out. But it also increases machine performance by using the knowledge loop that I talked about in the previous slide in the lower loop. And the RDC services comprise a standardized approach to managing predictive maintenance program. So the customer values then, the strategic customer challenges are solved, and this is our perspective. Many people in the audience might have a different view and want to add to this list. However, we see asset criticality, maintenance strategy review, that kind of activity is much better achieved by an RDC. Asset location, we operate with marine vessels around the world in very remote locations occasionally, and having an RDC where we can centrally collect the data is extremely beneficial. Also in the UK, we have a lot of remote applications in tidal energy, wind energy. It's not easy to get to site, and using an RDC to store and collect that data is extremely valuable. Sometimes there's a lack of expert knowledge locally, and by having a centralized RDC, we can apply our expertise in a group setting to actually enhance the diagnostics and knowledge learning. And of course, there's an availability of resources within the RDC. So the key customer benefits that we think are delivered, there's certainly optimised operations. We've got many examples where we have sat in a sort of a three-way call with the remote diagnostic centre, the customer, and some application. Could be a ship, could be an oil rig, could be a wind farm. And we are talking in a three-way conversation, possibly streaming data into the RDC, looking at it almost in real time, and deciding on whatever the issue was. And we've achieved this with defining resonance conditions, etc., almost in real time with the customer. Key cost savings that come with the RDC involve a lack of software licensing. You don't need software licenses. You simply have an annual fee, say, and a setup fee to get onto the cloud. There are no upgrades required because the upgrades are done automatically via the cloud services team in Sweden. There are no PSPs. You automatically upgrade. So there's a loss of cost savings. The software can be really quite expensive. By simply having a setup fee and a seat on the cloud, there's a great benefit in doing this. These other two, reliability, availability, asset time improvement, and added asset information. This is really the application engineering tasks that I talked about earlier in the knowledge loop. This is where they enter into the whole RDC idea. And from this, we get an improved decision making and a much faster deployment globally. Using the RDC, you have a much faster action time. So we're going to look now at a little bit of the workflow, the diagnostics workflow. I'm going to split this up into three little chunks. You can see project and preparation. Then we're going to have data collection, monitoring, reporting, and then finally user feedback, improvement, and follow-up. So in the first section, which is project preparation, installation, commissioning, and startup, what of course we need to do right at the start is define the customer needs, the project scope, make the proposal, and sign the agreement. Okay. The next thing to do is then to decide on hardware, software, cloud connection. So are we going to use, for example, online systems, offline systems? And at this point, it's extremely important to involve customer IT, get their engagement. Very shortly after doing that, you will be talking about cybersecurity, absolutely for sure. Some years ago when we started this, it was simply a question of which hardware we're going to use, plug it in, let's get going, and off we go. That we're in change days now, and cybersecurity has obviously become increasingly important for all of us. So whenever we start a project, the IT and cybersecurity is right at the top of the list of the early actions to implement at the beginning of a project. The second phase then is the database and asset hierarchy. This can be designed by us or based on client desire recommendation. What we'd like to do, and what we have done, is to try to standardize the databases. And what we mean by that is setting the data collection parameters. We want to make them standardized across all our RDCs. SKF last year in 2019, and in fact just the beginning of 2020, it's a project that finished a few weeks ago, where all the RDCs in Europe came together, and we attempted to standardize all our databases according to parameters such as how many lines of resolution, how many of the maximum frequency for certain applications, and how many averages. All that data, signal processing type parameterization, was standardized across a group of assets. Interestingly, for a handheld data collection situation, that led to a great reduction in the amount of time it took to collect data. So again, standardizing database is quite an important task in this early phase. The other point here about system settings, that's really about how often are you going to collect your data in terms of when are you going to collect trends, when are you going to collect dynamic data such as time waveforms and spectra. And this is quite important because this sets how much bandwidth you're going to use, how much data storage you're going to require. So these settings are quite important to understand at the beginning. Some clients only want data collected every few hours, every 8 hours. Some clients in certain applications require that data to be collected every minute, depending on the application. And it's important to set that and understand what the implications are for database size and data transfer. Finally, in this section, it's important to have all the kinematic data of the assets to achieve a high quality analysis. And by that, we mean process type parameters. If you're dealing with an oil rig, for example, pressures, flows of systems. Also, all the data regarding the machine itself, what bearings are fitted, its power, all of that sort of information needs to be input into the database. And this becomes increasingly important as we move to a situation where we're moving away, say, from doing analysis on alarms, but we're using auto detection schemes, anomaly detection, automated fault diagnosis. All of that information is required to enable those sorts of tools to function. It cannot function on just spectra and trend alone. Moving on to the data collection and monitoring and reporting. Obviously, at the start, we said there's the normal data collection that we get, trends, spectras, etc. And we can look at that and make recommendations on it, have alarms set, etc., and make decisions around exception reporting. So at the data level, we would have control of alarms and vibration analysis. When we move to a reporting type situation, this tool here is an SKF results reporter. It's our reporting interface where all of the reports are stored, and it's a repository for reliability data too. This is where the event reports sit, and other tools such as the compliance matrix. Other dashboards include the concept of insights. This is our new SKF Enlight Center environment where we have an insights page, and an insights page tells us if there are common themes or faults across the machine, asset, plant, based on the input, the information that's been input, the kinematic data, and also the data that's been collected via offline or online data. So the insights tell us something, say, are we having a large number of bearing defects? Do we see unbalance across the machine? Have we got some problem with data system status? These are the insights that come out of that kind of automated analysis. And so this is becoming increasingly important within the RDC. Some other optional type reports for online systems. You can get individual status reports where we want to know the status of the system from day to day. This is separate from a data analysis situation. This is simply asking the question, is the system healthy? Are all the sensors healthy? Are all the acquisition devices actually connected and transferring data correctly? In the UK, we also provide some specialist green reports based on the Canal Society recommendations, DNV, and AES. Those types of reports sometimes require specialist type set piece surveys to be done, or operational requirements on a ship to run a ship at a certain speed or a cluster at a certain RPM. And we also do those reports and place them in our reporting repository too. The reporting principles that we have are certified analysts, at least qualified to VA2. A lot of the analysts now in SKF in the UK are qualified to VA3. This is particularly important for organisations such as DNV ABS, where there are very strict rules around about who can do reports and who can approve them. We have a robust approval process where we have at least two people authoring and approving a report before it's issued. Again, the approver will be similarly qualified to either VA2 or VA3. All of these reports are either emailed or held in the results reporter dashboard. The results reporter dashboard also enables us to analyse assets applications by fault type, severity, and condition monitoring technique. So all of these processes reside in the monitoring reporting section. The user feedback, improvement follow-up. This invariably involves talking to the customer, of course. Feedback to SKF and interaction with the customer is crucial. We would want to not only improve optimization of the measurement setup, and when we can all see the data together in an RDC environment, that's much easier than having standalone databases in different parts of the world. We can carry out reliability type activities such as identifying bad activities. This is a plot that's come out of Results Reporter. Again, very useful insights can be gained quite simply by correctly inputting fault type data. We can improve the performance of the machines with SKF knowledge and application engineering. Application engineering is a key part of the way in which the RDC operates. Over the past year or so, without wanting to turn the application engineers into jacks of all trade, but we have actually gone through a program of improving and the knowledge of the application engineers around about vibration condition monitoring in particular. We've gone the other way, learning a little bit about application engineering. And in the Aberdeen office, we have one of the engineers who's qualified to the A2. He is on a program with the application engineers in Luton, going down, teaching. He's being taught about application engineering, and similarly, he's passing on information about knowledge about vibration to the application engineers. So we see the application engineering as absolutely crucial within any RDC setup and flow. And of course, regular review meetings and follow up with the client. So in the UK then, the types of customers we serve tends to be end users and owners and service companies and what we call the CMP, Certified Maintenance Partners, of which there are several in the UK, all sitting on our cloud too. So if it's appropriate, we could be sharing sharing analysis with the CMP partners in this sort of loop. Industrial segments that we serve, pretty much everything in the UK, no particular order here. Renewable energies, wind turbines, increasingly tidal turbines, industrial size prototype arrays now operating offshore North Scotland. The marine industry, extremely useful to be able to use an RDC type environment to get data from fleets of ships, transfer that to a central place. Oil and gas, a little bit like ships, because oil rigs are offshore, of course. A lot of food and beverage, pulp and paper, and increasingly in the UK over the past 2 years, railways. We've got a set of about 1,100 sensors fitted to wheel bearings on 2 fleets of trains operating. One is operating in the north of England and the other on a busy commuter network in the south of England. All of that data is being processed by the RDC on a daily basis. Applications, again, pretty much all types of machine, marine thrusters, railway bogies, cranes, fans, pumps, the usual things. Marine thrusters are interesting because they tend to operate at different speeds all the time, and that presents something of a challenge to both data collection and analysis. Having an RDC is extremely beneficial in doing that effectively. A little bit about the RDC footprint globally. You can see we've got RDCs worldwide, a bit of a cluster in the UK, in Europe, sorry, not the UK, in Europe, Hamburg, Sweden, Benelux, Italy, and France. We have very good contact with our friends in South America, in Brazil, and in the Far East. And the RDCs all come together. We have projects that run in the UK and the rest of Europe and the world to bring all the RDCs together into one common meeting environment to share knowledge and gain best practice. A little bit about the Remote Diagnostic Centre in the UK. Most, if not, well, yes, most of the contracts involve substantial remote analysis due to the availability of data on the cloud and the ability to provide lower cost remote analysis. It's a very attractive feature to clients when we're setting up RDCs, the fact that you can do this at really quite low cost. The new Remote Diagnostic Centre opens in Aberdeen in September 2019. 30 experienced consultants across the UK with condition monitoring engineers, application engineers, service coordinators, and we are providing a really very high level of collaboration between the various teams that form the RDC, from data collection, application engineering, analysts, and then a little bit about the RDC customers that we serve. A little bit more about the Remote Diagnostic Centre in Aberdeen. We tend to use an REP approach, rotating equipment performance, where we're looking at not just one stream of data, but all of the information from a machine and putting that into a more holistic package of analysis. And then the remote diagnostic condition monitoring customer assets, including analysis, anomaly detection, reporting and insights. And then again, following up with improvement projects with application engineering. You can see that application engineering is a theme that runs through this entire idea of using an RDC. They're very, very important, of course, interaction with the customers. Finally, then, the RDC in the UK, we think we're monitoring approximately 53,000 bearings on about 15,000 assets, 15,300 assets across all industries and applications. So I think that's really all I have to say about that. If anybody's got any questions and answers.
No, Geraint. I haven't received questions from the chat box for the moment.
Okay.
Maybe there is someone who has a last-minute questions. Geraint is here, so take the opportunity to ask him if you want. Okay. Thank you very much for your time. Thank you very much for attending this webinar, and hopefully we will see and listen again somewhere during the upcoming webinars in the next few weeks. visit our landing page to see what topics might be of interest for you, and sign up, please. If you have some questions, you can, of course, also contact Garin directly or your regional sales manager from SKF. This session has been recorded, so it will be distributed to you later today or at the latest tomorrow morning, together with a copy of the slide deck. So you will be able to read and listen to it once more or share it with your colleagues. For now, thank you very much for your time and your attention, and stay safe, and hopefully we'll see you next time. Thank you very much.
Okay. Thank you.